To the rational functions video. Hopefully you paid a lot of attention to the fact that wholes are generated by the same factor on the top and the bottom. You will have to factor out these equations in order to find those wholes. Vertical asymptotes. So anything that's not a whole is a vertical asymptote. So in this case, -2 and +2 are vertical asymptotes. In this case, 3 is a whole. So there's only one asymptote at -1. Let's take a quick peek at those. So when I look at, and then you can verify graphically, you can see that here I've got an asymptote at -2 and an asymptote at 2. That's what was predicted by my equation. And then here I should only have an asymptote at -1. So let's take a look at that one. Oh yeah, that's what I'm talking about right there. There's only one asymptote. Good. So if it's not a whole, it's a vertical asymptote. Another name for a whole is a removable discontinuity. Why do we call it removable? I will tell you why. Because if I take a look at this right here, and I ignore that, yes, I know when x equals 3 I have a whole. So this equation without the whole would be 1 over x plus 1. Meaning that if I plug in this number here, the whole, if that's the x value of the whole, the y value of the whole would of course be 1/4. So the whole is located at 3, 1/4. It's removable because if I simply define the function at that point, I can make it continuous. Good. All right then, end behavior. Obviously we have end behavior here that's going off to the right, that's going off to the left. What we're really talking about is there's three things here. We can have a case in which we have a function that we call top-heavy, and we'll look at, say, yes, the power on the top exceeds the power on the bottom. In this case, there is no limit. It continues to infinity. Okay? There's no asymptote. And now again, we're talking about horizontal, not vertical. Vertical are easy. Those are the domains. These are horizontal. The other case you might have is, say, 3x squared plus 1 over 2x squared plus 1. I call this a match. And when I say match, I mean that the powers match. When the powers match, you take the ratio of the coefficients, which in this case is 3/2. Yes? Good. And then finally, obviously, we had top-heavy, we had match, and then we'd have bottom-heavy. And we can actually just flip that one right over. 2x squared plus 1 over 3x squared plus 1. Yes? In this, oh, excuse me, let's do cubed here. All right, so now we have the bottom bigger than the top. That's bottom heavy. And whenever it's bottom heavy, the asymptote is 0. Okay, so there are three cases. There's no asymptote, there's a horizontal asymptote in a match situation, and then there's an asymptote of 0. Those are the only three possibilities. As far as end behavior goes, what we're going to do is write our limit notation again, and we will say the limit as x approaches negative infinity of the function would simply be, in this case, it's going to be 3/2. And then obviously we would do this as well, going to the right. That would be 3/2 as well. Let's take a quick look at one of the equations we just looked at here. Here's, how about our examples? Oh, here, how about this one right here? So this says, because that's the first power and that's the second power, this should have a horizontal asymptote at 0. And if we inspect the graph, we see right there along the line 0 that the function as it moves to the right is going to approach 0, and the function as it moves to the left is going to approach 0. And if I zoom out, you can see that it just basically forms a perfectly vertical green line there. Good. Enjoy.